our next speaker here is Murat Sever from Turkey, Tango Alpha 2 Bravo Tango Oscar. And it's very interesting for me because I've also been into SDR teaching. And we also thought about, oh, how can I teach this topic? And well, in general, this is what we're here for as an SDR academy. And therefore, you need things, tools, you need devices, you need a methodology, you need a path, you need all sorts of thoughts and things. And this is what this talk is about. It's about how to teach SDR. And so please give Murat a warm welcome here on the stage.
Thank you.
Good to have you here.
Thank you, Marcus.
The stage is yours.
Thank you. Hi, my name is Murat Sever. I'm a software developer and a part-time lecturer at TA2BTO University, located in Ankara, Turkey. So today I'm going to talk about, present our educational kit called HaKi, or Communication Kit in English. With HaKi project, we aim to introduce communication systems to undergraduate students and to introduce communication systems to people from all ages. So this presentation will be a short one and it will be an easy one, I promise. And first of all, I'm going to begin with motivation for starting over such a project and then give you information about the kit, communication systems kit. So we have developed undergraduate level laboratory coursework to teach communication systems to students, undergraduate level students, using software-defined radios. We also developed a graphical user interface, simple GUI, to illustrate, to demonstrate use cases of the kit. So at the end, I will conclude with our future plans. So let's look at together what are the problems first. Let's see. Communication systems are complex in nature. They include many subsystems. They involve theory that is deep and hard to understand. Most of the time, laboratory work only consists of simulation experiments, or there are other hardware-based tools, both expensive and difficult to set up. So we have time and place restrictions. And so our solution we are looking for should have open architecture. It should be modular and extensible, should include real-world signals, and should be software-based, supporting also professional development of students as well. And it should also provide us remote work opportunity. So with these considerations in mind, and our platform, our solution should be again based on a new platform that will also allow us to run other types of projects too, like computer vision, robotics, or other AI applications, so that we can reuse it in our other projects too. So with these considerations, we started HaKi project, and we would like to engage students more into communication systems using SDRs. So we chose RTL SDR for the project. It's because it's cheap and meets our requirements. So we are only receiving only. And we also chose NVIDIA Jetson Nano single board computer, the right top one. So it's very similar to Raspberry Pi, but it's a heterogeneous compute platform to run broad range of applications. The prototype also includes a touchscreen display, so it becomes portable and standalone. It can work as a standalone device. We are utilizing just nano SDR distribution from SDR technologies for Jetson Nano. So it's pre-installed with all software components. So the user is eliminated from boring stage of installing software onto it, because most applications are already pre-installed with this image. So we developed our undergraduate curriculum using these tools, and it's modular. It's based on Jupyter Notebooks, actually. It consists of many modules based on Jupyter Notebook. There's a module on DSP at the beginning that I introduce GNU Radio to students, and I use GNU Radio throughout my classes, because it can be used for simulation, it can be used for it allows us to use many SDR, it supports SDR devices. So after introducing students who are new to the DSP world, I teach SDR, actually RTL SDR in the SDR module. In Python module, I have some Python use for new to Python, who hasn't used Python at all, and its libraries. And I also have MATLAB courses, because Jupyter Notebook supports both Python language and MATLAB language. I have all courses for Python and MATLAB. And all the remaining modules are for communication systems. So notebooks include records from real-world signals. Students also apply their algorithms to the live signals they have taken themselves. And in classes, I also transmit using HackRF. So they have opportunity to catch those signals with low opportunity to be found on the air. Students record them and then complete their assigned tasks. So GNU Radio is used all throughout the course, both signal analysis and offline and real-time demodulation purposes. I also would like to mention that I also use GitHub Classroom application. GitHub Classroom application is free for academic use, for educational use. And so this way you can easily manage your assignments and even automatically grade them. It also allows to watch progress of your students on their assignments, and you can give them necessary comments on their commits, so it provides a constructive collaboration environment. We later developed a simple graphical user interface that easily launches actually the installed software with just one click, making it easier even to use for ones with little knowledge on the device or tools. Left image shows a screenshot, and actually user just touches on these buttons, these image buttons, and then he can just watch spectrogram, see signals easily. So this way user can easily watch most common signals like wideband FM, broadcast FM, narrowband FM, and easily watch ISM bands or watch signals emitting from aircrafts. And they can also start IQ record with record button. We have two big supporters for our project. One is NVIDIA. NVIDIA supplied us Jetson Nanos through their academic hardware grant program. We are also one of the grantees of ARDC. They support us to develop SDR-based education materials and help us improve our course content through their education support program. I would like to thank to them. So with this new curriculum, I taught SDR-based laboratory course, and I gave this course 2 times so far. I received very good feedback. According to surveys, students tell they grow interest in communication systems. And also they say that they learn tools that are helpful in their future careers. So we are going to continue with SDR-based education in our communication study for laboratory work. So this project is work in progress. We have many future plans. We will add more modules, mostly digital ones. I would like to add more digital examples. And I would like to add also more advanced concepts. Students now only can see frequency division multiple access methods, but there are other multiple access methods. And I would like to add more examples of new generation communication systems, which are even more complex, like cellular or Wi-Fi. So for this reason, we are going to buy more capable SDRs. These are called step-up SDRs. And we also want to use GPU acceleration. And NVIDIA has CUDA and QSignal, and its signal library to run on GPUs. And we also want to have useful deep learning applications, because Jetson Nano card is well suited for all of these purposes. So thank you for the interest, and thank you for listening to me. And I would just like to just maybe demonstrate have a little demonstration on stage. So this is the prototype that I have. And actually, this is now working. We are listening to wideband FM, and I can just close this window, and this is the main window. Actually, I can launch GQRX by touching most of the buttons, and I can launch ADSP. I can watch ADSP signals using dump 1090 with just one click. To monitor ISM band, I just clicking on ISM, and it starts RTL SDR with configured frequency. And when I just click on my car key, and you can see the peaks, and you can introduce communication systems this way to newcomer and who doesn't know actually anything about communication system using this with one click. And this is for to introduce communication systems to newcomers. So thank you again. Thank you.
All right, thank you very much. So, yeah, quite interesting. So you've brought a kit. I haven't seen it from back there, from my... Okay.
It has just a nano single board computer, and the above card is sound card, actually, to just listen to demodulation sound after the demodulation step. And I have speakers, and I have touchscreen display to be used in introducing system to others.
Okay. Was it used more frequently for... Oh, is that my audio? 433? No, it's not. Could have been 433. So. Was it used more frequently in further projects to create, let's say, SDR as an amateur radio?
Actually, this way, students work on their Jupyter notebooks. Yeah, they are using it as a headless device most of the time. I just included a touchscreen to introduce concepts. Yeah, and students use Jupyter notebooks. They complete their assignments in the notebooks that I have given them, and they commit and push them to their repos, and we assign them. This way it works. But I also would like I can improve the software, so because there are other software already installed within the distribution, nano SDR distribution. So there's also GPU capability, so we can also leverage that capability, I suppose. So we have plans for future like this.
Okay. Regarding the audience, so, well, your audience at home where you're teaching, what kind of people are they? What do they bring with them? What is their knowledge they bring into your lessons?
Yeah, I have broad range of, they are all from electrical engineering, but they differ in, how to say, there are students who have not used terminal prompt, command prompt or terminal at all. So they learn how to use command prompt and they learn how to deal with Jupyter notebooks, and they may come without any knowledge of Python. So they differ a lot. And these environments actually, Jupyter notebooks actually allow me to give information about that. And also it has interactivity, so they write their code into the notebook, and that's the thing they like the most.
How long does the class take? So how long does it take from the very first moment when they enter your classroom the first time until they come out and they're skilled SDR engineers?
Yeah, that takes 10 weeks. This is a 10-week program. In the first 5 weeks, I only have SDR introduction, DSP introduction, or Jupyter Notebook introduction. So after 5 weeks, we are able to play with signals, communication signals. So 5 weeks for preparation to the course and the technology and the tools, and other 5 weeks for communication systems.
Okay. Well, are they also skilled in, let's say, network engineering? Because, well, most of these devices in the meantime are network devices operating over the internet somehow, or at least to some degree. Do they also bring skills in network engineering?
Oh, some students like SDR concept, and they go further, like installing other software into their computer and trying things, because we are giving them RTL SDRs for their use during the course, during the term. And not network, but they go for listening, they go for digital modes, and some very few of them are interested in amateur radio, unfortunately, but they know we introduce them to this world, SDR world, and into the radio world, and they experience it themselves, and they just watch. They can just tune to any frequency RTL SDR allows them. So we open doors for them, and some students go further.
Okay. So where is the antenna here, or the HF input?
So mostly this is dipole antenna.
Here, okay.
Yeah.
Yeah, okay, I've seen it.
I have
okay,
RTL SDR.
yeah, okay, good. Yeah, because a little it reminds me of the STEM lab, the Red Pitaya, a little, right? In the Red Pitaya, you don't have the RTL SDR, but you have separate hardware, and in the back end you have well, some kind of embedded computer. Well, generally speaking, there is very little difference, or next to no difference, between using such a piece of hardware as a receiver or transmitter, and on the other side as a measurement device. Do you also support the idea of using your equipment as a measuring device?
Oh, I have not think that way. In the future, in the near future, I would like to add more digital examples, maybe watching meteorology balloons and other technologies like cellular network, because with more capable SDRs, I can show them how to build a cellular network, so they can feel the power of software-defined radios. So I would like to go that way.
Okay. Right. Are there any questions from the audience? Have you been teaching SDR to anybody? Not yet? Would you like to teach someday? Yep. How would you do it?
I think the threshold is in the DSP part. That's the gap where the ham radio community, they understand the superhead, but they don't understand the digital signal processing part. And then people try to explain that, and they start to talk about bits and things, but they go, it doesn't work. I'm still searching.
Yeah.
The orange one? Okay, good. Yeah, that's also what I've seen.
Yeah.
In the community, we have a lot of really very, very good electronics engineers.
Yeah.
But there is a big gap. I always say, well, in German, it's Strom, right? It's not current, but yeah, the German word is Strom. And the English word then is data stream, which is very nice for the German language, because I always say, yeah, the switch over from electrical Strom, current, electrical Strom, over to Datenstrom, data stream, this is the hard part, right? And well, in fact, it's about, well, we're talking about the same topic, but it's a medal with two different sides. And the other side is mathematics. And I think discrete mathematics and complex mathematics is something which is very hard to grasp if you like to tinker with a soldering iron. And but it needn't be the case. It's not really such a big gap. And this was also my experience when I started with this topic a long time ago, because it's just about an abstraction layer that, well, you're describing the electrical sine wave or whatever you have there, and you're working with the description. But in the end, you're doing just pretty much the same thing. I mean, if you're thinking about a voltage divider, well, okay, I'm taking the amplitude value and I'm multiplying a decimal into it, and then it's the same thing as a voltage divider, but just on the description level. So in general, this was my experience about teaching, and I always try to place the analogies and show, okay, in the old world, or well, it's not the old world, but in the analog worlds, you're doing it this way, and this is the next step. And if you have a block diagram, and there you have a block diagram. When we think of GNU Radio, there you also have blocks. You also have block diagrams, and in between those blocks, you have a data stream, and not an electrical Strom, in the German word, right? So this was my experience. Do you also use such examples in your teaching?
What kind of?
So examples like comparing the analog world with the description level in SDR.
So in the DSP module, I'm using GNU Radio with sound cards, for example, before entering into the RF world. So because they can just generate a tone and then use filtering and see effects, aliasing effects on the generated tone, see how to sample, what must be the sampling rate. So GNU Radio is a good tool for education. Yeah, it can be used in simulation. It can be used any hardware device like sound cards easily, and then later on SDR devices. So GNU Radio is the biggest tool, but I also introduced them open tools, open software like GQLX or SDR in Windows. So they learn both general purpose SDR applications. They learn also GNU Radio, a software tool that they can do everything with a tool. And they also learn Python for programming. And the more focus will be on software. But those other tools are, I think, in my opinion, are necessary too, because they just allow a quick introduction. After they see how to implement and see the effects of those concepts, they can write their own code with Python using libraries. Yeah, we proceed like this.
Okay, interesting. Any Fragen im Chat? Okay, we have a question in the chat.
There's also
I have to read it.
I think, yeah. There's also a question there.
There is another question. Okay, I'll give the microphone, and in the meantime, I have a look at the chat.
So I'm not in the position to teach about SDR, but I'm learning myself. And in that regards, I stumbled about a book by two people. It's Jack Purdom and Al Peter. And those two have written a book, but they said, okay, just remain on the theory is not good enough. They want to make it accessible. They want the readers to experience it themselves, and so therefore they complemented their book with a set of schema, a set of PCB files, and a piece of software. So you are able, based on their instructions, to build yourself a software-defined transceiver. And the interesting part about the hardware is that it is built modular. So it's not one big PCB where everything is on top of that, but it's several small PCBs. And so if you want to experiment with one component, for instance, with the quadrature exciter or maybe the filter, so then you just have to redesign that one single board and can keep the whole rest. And this I find a really interesting project.
Thank you.
So the authors are Jack Purdom, W8 Tango Echo Echo, and Al Peter, Alpha Charlie 8 Golf Yankee. And they call it the SDT for Software Defined Transceiver, T41 for the Teensy 4.1, which is the processor used, and EP for Experimenters Platform. So that's the project. If you search for that on the web, you will find several results. One is on GitHub, where the source code is located, but the main hub for the community is a group.io community, which is called something like software controlled radio or something around that line. I don't recall that now from my head.
Thank you for your comments. Yeah.
Okay. The last question from the chat is, who can attend your class? How much does it cost? And will it be held online?
Yeah, the course I give at the university is in person. We just give a 2-hour lecture. We have 10 weeks, as I said. And also, this tool costs less in the history, but nowadays it's a little bit more expensive because of just a nano card. But I think it's around $300 now to construct such a setup. Yeah, around $300.
Okay. Good. So, any more questions? No more questions. So, thank you very much for coming. Thanks for this interesting talk.
Thank you.
And hope to see you again soon.
Bye.